Davey Gann here with another question from your Hayes and Harris Math SL textbook. This is exercise 5a, question 7. It says, consider the function f of x is equal to x take 2 squared take 9. And don't be frightened by this notation. It shows up every now and again. I really hate it. I always just rewrite it. F of x equals x take 2 squared take 9. That's all it's saying. It's saying f varies according to x, or f varies with x according to the rule, this rule. So f of x is this function. It's the same thing. First off, we're going to graph this function. So let's turn to the calculator. We're going to go to Home. We'll open a new graphing graph. We're going to graph that function, which is x take 2 squared take 9. All right, we see the graph there. Let's adjust the axes a little bit so we can see the vertex down here. All right, and we get the graph. Looks like there's some axes intercepts over here, axis intercept over here. All right, we've got the graph. Part B says to find algebraically the axes intercepts. So that's the x-intercepts and the y-intercepts. For the x-intercepts, these occur when f of x is equal to 0. The y-intercepts, or the f of x intercepts, occur when x is equal to 0. So we'll test the function under these two conditions. When f of x is equal to 0, we get 0 equals x take 2 squared take 9. Now to solve this, we could try and FOIL this out and solve the quadratic for x, but I'm actually spotting a shortcut. What I'm going to do is I'm going to move the 9 to the other side. And now what I have is, on both sides, something squared equals something squared. I know what the square root of 9 is. It's plus or minus 3. So square root of both sides, square goes away over here, and I get plus or minus 3 on the other side. Anytime you take a square root, results in plus or minus. Because it's plus or minus, that means that there might be two solutions. There might be a solution when 3 is positive, and there might be a solution when 3 is negative. I'll solve for both cases. When 3 is positive, I get x is equal to 5, and when 3 is negative, I get x is equal to negative 1. All right. What about the y-intercepts? Those are the x-intercepts. What about the y-intercepts? Let's solve for when x is 0. We get f of x, or f of 0, is equal to 0 take 2 squared take 9. So there's our function there. We're just going to let x be 0. Zero take 2 is negative 2. Square that is positive 4. And we get negative 5 for the y-intercept. All right. Part B says to use technology to check that the x-intercepts are negative 1 and 5 as we predicted down here, and that the y-intercept is negative 5 as we predicted right here. So we'll jump back to the graph. On the graph, what we'll do is we'll go to Menu, and we're going to analyze the graph, and we are going to look for the zeros. Those are the x-intercepts. The lower bound means look below the x-intercept, so we'll select below. And the upper bound says that, yep, there is a 0 right here at negative 1 comma 0. That's our x-intercept, negative 1. We'll do it again to get the other one. Yep, looks like it's 5. No worries there. For the y-intercept, what we're going to do is trace the graph and find the value of the graph when x is 0. So we'll go to Menu, we're going to trace the graph, and we'll put it right where we wanted it, but I'm just going to type in 0 to say when x is 0, give me the function, or the value of the function, and yeah, it gave it to me right here. 0, -5. So that's our y-intercept. Lastly, we want to use the technology to check that the vertex is at 2, -9. So one more thing we want to do is get this minimum. So menu, analyze graph, get the minimum, lower bound below it, upper bound above. And we get that the vertex is at 2, -9, just as predicted.